We present FRAN, a novel face re-aging network that preserves identity while allowing controllable and continuous re-aging of faces in images and videos. Over the last few years, there has been an exponential use of digitally aged actors in movies, TV series, and advertising. Digital re-aging is quickly becoming an essential tool in every visual effects studio. There are commonly two approaches used to re-age actors in movie productions. The first one involves a traditional 3D computer graphics pipeline, which requires building a complete 3D re-age face rig, then requires to animate it, and finally to render it in the scene. This 3D process is very complex and time-consuming and generally reserved for hero characters, occupying a lot of screen time, including many close-up shots. The second approach involves a purely 2D image editing pipeline. The present-day actor is often filmed on set and their appearance is directly edited on the image plane, without requiring reconstructing the 3D geometry. Again, this process requires countless hours of highly skilled artists to get right, as the actor's appearance needs to be touched up for every frame in a consistent and believable manner. Recently, several new deep learning methods were proposed to tackle the image-based re-aging problem. While producing convincing single-frame results, none of the proposed methods tackle video-based re-aging and do not output consistent results if applied on videos. Here we show a couple of examples of the type of output such existing methods will provide. On top of that, these methods often don't preserve the identity of the input subject, meaning that the re-age result would look like a younger or older person, but not a younger or older version of that input subject. Finally, the majority of those methods are limited to low-resolution images and requires the face to be carefully aligned and more or less front-facing in order to produce any result. We remove those drawbacks and introduce a novel method for aging and de-aging a person in an input video, which provides stable results under various lighting and pose conditions at high resolution. Here on the left is the input video and on the right is the corresponding result generated fully automatically by our method, taking just under 5 seconds per frame. A key observation of previous methods is that while losing the identity if given a real input image, these methods allow to generate realistic age progressions when using fully synthetically generated still images as input. We leverage this and use a generative model to create several thousand images of random synthetic identities. For each of them, we leverage a recent method allowing to re-age images projected into the StyleGAN latent space. This allows us to build a training dataset for our re-aging method, which we formulate as a fully convolutional neural network. This network takes as input an image to which we append the initial and target ages as extra channels. The network then outputs the predicted aging deltas which are added on top of the input image to generate the re-aged face. Please see the paper for more details about the network architecture and training procedure. We now show results, starting with de-aging a performance. Here we see how robust our method is to various head motions. We now show the same performance, but this time aged. Finally, we show the same performance again, but aged even more. While existing methods can be run on the frames of a video, they require a face alignment step. Here we show the same de-aging sequence compared to the state-of-the-art methods. Note that our method does not require the face alignment step, but we do it for better comparison. We now show the same comparison, but this time aging the performance. Note how existing methods exhibit temporal artifacts, and some of them do not maintain the identity of the subject. Here we show the same comparison, de-aging another subject. And again, the comparison with the same input performance, but this time aging the subject. Very recently, Taban and colleagues introduced a method allowing for video editing using StyleGAN. Here we compare the result of FRAN against their method for de-aging. On the left, we show the result of their method, and on the right, we show the result of FRAN. And here we show the comparison with their method for aging. While temporally more stable than previous work, their method still suffers from some temporal inconsistencies. We show here two continuous age progressions generated by our network for two individuals. We now show another DH performance. Note how our method is capable of handling fast camera motion, which could cause motion blur. We show the same performance, but this time aged. And aged even further. Our method also outputs consistent re-aging under various lighting conditions, which we show here in this de-aging example. Here we show a performance of an actor for which we fix the input age and slowly increase the target age over time. Note how our method produces smooth age variations from frame to frame, even though it was only trained on a discrete set of age deltas. Finally, to make FRAN more accessible for artists, we created a nuke node that allows the user to directly see the editing results at an interactive frame rate. Artists can control the input and target ages, giving a lot of flexibility and making FRAN very practical to use. Here in this screen recording, we show a user exploring various settings such as changing the target age, the input age, and also removing the segmentation mask which sets the target age only on the skinned pixels. Note that this recording was not sped up. We have presented FRAN, a production-ready face re-aging method specifically designed for the complex problem of re-aging real faces in videos while preserving the identity of the actor, simplifying a very common visual effect workflow.